Right, in continuation with our previous class, we are going to solve a topic called linear differential equation. Right, a problem is given to us, dy by dx plus 1 by x into y is equal to y cube. Generally, linear differential equation will be of the form dy by dx plus py is equal to q. Here p and q are what beta? Functions of x alone. These should be functions of x. But if you could observe carefully, here what is happening? Q is here y is there and y cube is there, but this can't be a linear differential equation. So I would like to introduce a new concept. That concept name is Bernoulli's equation. So now we are going to discuss a topic called Bernoulli's equation. What do you mean by this Bernoulli's equation? An equation of the form dy by dx plus py into q into y power n is called Bernoulli's equation, where p and q are functions of x alone. So how to solve this particular Bernoulli's equation means divide throughout the equation by 1 by y power n. So what happens? 1 by y power n dy by dx, this becomes 1 by y power 1 minus 1 by y power 1 minus n into p is equal to q. So what happens? In these problems there is a rule, we need to put 1 upon y power 1 minus n is equal to t. So this whole thing will turn down to dt by dx, and this turn down to t, and finally the differential equation will turn down to dt by dx plus pt is equal to q. That means the differential equation has been turned down to linear differential equation, and we have done a lot of problems basing upon linear differential equation in our previous classes. According to that, we need to solve the problem, right? Once again I am repeating, what do you mean by Bernoulli's equation? Means an equation of the form dy by dx plus py is equal to q into y power n is called a Bernoulli's equation. For procedure of Bernoulli's equation means we need to divide by y power n on both the sides, and after dividing by y power n on both the sides, we need to put 1 upon y power 1 minus n is equal to t. So this becomes dt by dx plus pt is equal to q, which turns to linear differential equation, and procedure is as usual, right? Now we shall be solving this problem. So this is given. So what happens? 1 by y cube dy by dx plus 1 by x into 1 by y square is equal to 1. Okay, is equal to 1. So what I will be doing? This I will call as 1. Put 1 by y square is equal to t. That means y power minus 2 is equal to t. Differentiate with respect to x. Minus 2 into y power minus 3 dy by dx is equal to dt by dx. So what happens? 1 by y cube dy by dx is equal to minus 1 by 2 dt by dx. So what I will be doing? I will call this as 2. I will call this as 3. So what I will be doing? Put 2 comma 3 in 4 in 1. Put 2 comma 3 in 1. Then what happens? This whole thing, in place of this whole thing I need to write minus 1 by 2 dt by dx and plus 1 by y square. 1 by y square means y power minus 2. I need to write as t, and here t by x, because 1 by x is there, that is equal to 1. So finally what happens? We shall see. Finally this will turn down to dt by dx minus 2t by x is equal to minus 2. If you could observe carefully, I multiplied with minus 2 on throughout the equality. So it becomes dt by dx minus 2t by x equal to minus 2. And if you could observe carefully, this is a linear differential equation. So solving linear differential equation means first I need to find integrating factor. Integrating factor means e power integral of p dx, that is equal to e power integral of minus 2 by x dx, that is equal to e power minus 2 into 1 by x dx, that means e power minus 2 into log x. So this is nothing but e power log of x power minus 2, that is equal to x power minus 2, that is equal to 1 by x square. Therefore general solution means t into integrating factor is equal to integral of q into integrating factor dx plus c. So what happens? T means t only. Integrating factor means what happens beta? 1 by x square. And q means what here? Minus 2. Integrating factor means what? 1 by x square plus c. So what happens finally? T by x square is equal to minus 2 into integral of x power minus 2 plus c. So finally what happens? T by x square integral of x power minus 2 means x power minus 2 plus 1 by minus 2 plus 1. So here I am writing, that implies t by x square is equal to minus 2 into I think minus 1 by x, because x power minus 2 can integral x power minus 2 plus 1 by minus 2 plus 1, and here c. So finally I am writing the solution over here. What we'll be getting means t by x square is equal to 2 by x plus c. Magar t is nothing but what beta? What we assumed as t? Y power minus 2. That means 1 by x square y square is equal to 2 by x plus c is general solution of, if I call this as star, this will be the star. So very important problem beta. This had been asked in our CBSE question paper. Right? I will be explaining once again. dy by dx plus 1 by x into y is equal to y cube. I call this as star. This is a differential equation, and this kind of differential equation we call as a Bernoulli's equation. So we need to divide by y cube on both sides. So 1 by y cube dy by dx plus 1 by x into y square is equal to 1. We need to put 1 by y square is equal to t. So what happens? 1 by y square means I can call it as y power minus 2. So y power minus 2 is equal to t. So what happens? Minus 2 into y power minus 3 dy by dx is equal to dt by dx. So 1 by y cube dy by dx is equal to minus 1 by 2 dt by dx. So this is 2, this is 3, this is 1. So we need to put 2 comma 3 in 1. Finally minus 1 by 2 dt by dx plus t by x is equal to 1. I multiply by minus 2 throughout the differential equation. So this becomes dt by dx minus 2t by x is equal to minus 2. So this is like linear differential equation. So we need to find integrating factor. Integrating factor means e power integral of p dx, that is equal to e power integral of minus 2 by x dx, that is called e power minus 2 into integral of 1 by x dx. This turns down to 1 by x square. Later I applied the formula, and this is our final result. Please copy. Right, we shall be seeing another problem in this particular Bernoulli's equation. And once again I am reading, what do you mean by Bernoulli's equation means? dy by dx plus py is equal to q into y power n, where p and q are functions of x or functions of x. So whenever this kind of problem comes, we need to divide by y power minus n throughout the differential equation. Right? So we shall see another problem based on this Bernoulli's equation. Here you had given tan y into dy by dx plus tan x is equal to cos y into cos square x. This is given. Right? So what I will be doing means I will be dividing by cos y throughout the equation. So what happens? Tan y by cos y into dy by dx plus tan x by cos y is equal to cos square x. So what happens? 1 by cos y. 1 by cos y means secant y. Secant y tan y into dy by dx plus secant y into tan x is equal to cos square x. Now we should be very, very careful in solving this kind of problems, right? So what I'll be doing means I will put secant y is equal to t, derivative of secant y tan y. So secant y tan y dy by dx, because we are differentiating with respect to x, is equal to dt by dx. So what I'll be doing means I will call this as 1, this as 2, this as 3, this as 4. So what I'll be doing means put 3, 4 in 2. So what happens? Wherever secant y tan y dy by dx is there, we need to write dt by dx. Secant y के स्थान में t, so t into tan x is equal to cos square x. So if you could observe carefully, this is a linear differential equation in t. So what I will be writing? This is a linear differential equation, LDE. LDE means this is a linear differential equation. Therefore, how we will be solving means, first of all we need to find integrating factor. Integrating factor means e power integral of p dx. This is p beta. So e power integral of tan x dx. So integral of tan x means what happens? Log mod secant x. So e power log mod secant x means I will take as secant x. Now later, therefore general solution. Therefore general solution. What is our general solution means? T into integrating factor is equal to integral of q into integrating factor dx plus c. So what happens? T. T means what here? T only. Integrating factor means what here? Secant x is equal to q. Q means what is there for us? Cos square x. Integrating factor means secant x dx plus c. So what happens? T into secant x is equal to, I think one cos x will be getting cancelled. So what happens? Cos x dx plus c. So what happens? T into secant x is equal to integral of cos x will be sin x plus c. Magar t means in place of t means I had taken as what beta? Secant y. So what happens? Secant y secant x, secant y secant x is equal to sin x plus c. So this is nothing but what? Secant y is equal to secant x means 1 by cos x. I can transfer to that side. So sin x cos x plus c cos x is the relation which satisfies the differential equation 1. So with this we completed problems based on Bernoulli's equation. Please copy. In differential equations, now we are going to start another topic called as exact differential equations and differential equations of higher order. See here, what do you mean by exact differential equation? We need to observe carefully. Before starting up this topic and various formulas, I would like to tell what do you mean by this exact differential equation. Exact differential equation. An equation of the form m dx plus n dy equal to 0. A differential equation of the form m dx plus n dy equal to 0 is known as an exact differential equation. I am repeating once again. A differential equation of the form m dx plus n dy is equal to 0 is known as a differential equation, is known as an exact differential equation. Here m comma n are the functions of x comma y. That means m comma n can be an implicit function, right? Now for solving this kind of exact differential equations, we need to remember the following results or a formula. d of xy means you can write as x dy plus y dx. If you could observe carefully how we got all these results means it is like finding like UV rule only, no? So d of xy means x dy plus y dx, and d of x by y means y dx minus x dy by y square. Some people may ask me, sir, how you got all these things? So here I will be showing d by dx of xy. If I take, what happens? X into y ka derivative means what happens beta? Dy by dx plus y. Now later what I have taken? D by dx of xy is equal to x dy plus y dx divided by dx. So finally I can write like this: d of xy is equal to x dy plus y dx. This is a simple proof, but all these proofs are not required. Just we need to remember this particular result. So later d of y by x means x dy minus y dx by x square, and d of log of y by x means you can write as x dy minus y dx upon xy, and d of log of x by y means I can write as y dx minus x dy by xy, and x dx plus y dy is equal to 1 by 2 d of x square plus y square. And here also d of log of xy means I can write as x dy plus y dx by xy, and d of tan inverse x by y means I can write as y dx minus x dy upon x square plus y square. You please remember these results for solving various problems. Now we shall start problems. Right beta, now we shall be seeing how to solve exact differential equations. I told various results to remember also. I will be taking 2 examples in today's class, that means 2 problems I will be taking. If you could observe carefully, both the differential equations given on the board are exact. How can we tell whether these are exact differentials or not? Means it is of the form mdx plus ndy. Here also it is of the form mdx plus ndy, where m and n are functions of x comma y. So in today's class I will try to solve this problem. Right. So this is solution. What is our given differential equation? Means given x plus log y into dy plus y dx equal to 0. So this I can write like this: x dy plus log y into dy plus y dx equal to 0. Now later what I will be doing means I will write x dy plus y dx plus log y dy to one side. So I think this whole thing I can write as d of xy, and here this is log y dy equal to 0. So for my convenience what I will be doing, d of xy minus log y dy. Now integrate on both sides. So d of xy is equal to minus integral of log y dy. So I think integral and derivative will be getting cancelled, and so here xy, and in one of our earlier classes we have proved integral of log x. Integral of log x means I said x into log x minus 1. So here also what happens, x means minus y, minus will be outside, y into log y minus 1 plus c. I think y will be getting cancelled. So finally our result will be x into minus of log y minus 1 plus c. Very important result we should remember. Right, when coming to this problem, 1 plus xy into y dx plus 1 minus xy into x dy equal to 0. This is given to us. So what I will be doing means I will multiply y plus xy square dx plus x minus x square y dy equal to 0. So later what happens, that implies y dx plus x dy, and here if you could observe carefully, what is there, xy square dx minus x square y dy equal to 0. So if you could observe carefully, this I can write as d of xy by the result, and from here I can take xy common. If I take xy common, what I am getting? Y dx minus x dy equal to 0. So later what I will be doing? I will divide by xy throughout the equality. So what happens? Y dx minus x dy equal to 0. So later for my convenience, what I will be doing means I will be dividing by xy whole square, so that our problem might become very easy. So xy whole square I will be dividing. So what happens? D of xy by xy whole square plus, I think y dx by xy whole square means it is observe carefully, it is becoming like some formula, y dx minus x dy whole square. So I think one y will be getting cancelled and will be getting some, observe carefully, y dx minus x dy divided by xy whole square. I think we can remember a wonderful result. Observe carefully, or else something we can do, any magic here, please. Y dx, sorry, I think if I take xy common, there remains x dx, no? Xy whole square, if I take xy common, there remains y dx minus x dy, right?
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.